Today we're going to be solving Classical Mechanics by Thornton and Marion, Chapter 2, Problem 8. I just wrote down some important parts of the problem, the first being that the projectile has a velocity v0. It passes through 2 points, both the distance h above the horizontal. This will help us define our x-coordinates. And then the gun is adjusted for maximum range. This tells us theta, because we know in projectile motion, the angle which gives the maximum range is 45 degrees. So that's a given. Now we'll start by drawing our coordinate system and a picture. That's our projectile being fired. And there's 2 points, a distance h above the horizontal. And I'll call this x1 and x2. The separation is d. So delta x is x2 minus x1, which is d. Now you have 2 equations of motion, the x direction and the y direction. In the x direction, we know that the acceleration in the x for projectile motion is 0. And then in the y direction, we have the gravitational force. Now, if we integrate the y side, then we get y dot is equal to the square root of 2 over 2 v0 minus gt. Additionally, if we integrate one more time, we get the square root of 2 over 2 v0 t minus 1/2 gt squared. And the square root of 2 over 2 comes from theta, because in radians, 45 degrees is radical 2 over 2. Oops. We know in the x direction, if we take the components of our v0, v0 y, v0 x, and theta. So our v0 x is just going to be v0 cosine theta. It's going to be v0 cosine of 45 degrees, which is just radical 2 over 2 v0. Then if we integrate that with respect to time, radical 2 over 2 v0 t. Now from this y equation, we can solve for t and then plug it into our x equation afterwards. So for this, we're going to have to use the quadratic equation. So we're going to have negative 1/2 gt squared plus radical 2 over 2 v0 t minus y equals 0. Now we use the quadratic equation for t. just going to have to simplify this. Oops, this should be y, because y is a constant. Now the other thing we recognize is that y is just h, because that's our height here. So this is y. And that's about as much we could simplify for t. Now we have to plug this into the x equation to get x1 and x2, which we'll be able to choose the plus and minus with t for two different x's. So the first x I'll choose is the positive t to solve for x. So we'll call this x1. And then we'll multiply by t, but just use the positive answer. And now we'll have to go through some simplifications here. So first thing I'll do is distribute the square root of 2 over 2 times v naught. So what we did here is just set up an equivalent expression. We can actually prove that the square root of 2 over 2 v naught times the square root is exactly equal to 1/2 v naught square root of 2 times 1/2 v naught squared minus 2gh. And I'll show that real quick. So the v naughts and the 2's cancel right off the bat. We're left with square root of 2 times the square root term. So really all we did is just combine the square roots. Because you can just move this 2 inside the square root. If we square root both sides, then everything goes away, and you're left with the exact same thing. Just wanted to justify that. Then finally, we'll just write -1/2 v naught squared plus 1/2 v naught square root of v naught squared minus 4gh over -g. And that's our x1. So now we'll do the same exact thing for x2, except we're going to choose the negative answer for t. And so by following a very similar process, we end up getting 1/2 v naught squared plus 1/2 v naught You notice that the negative cancels out with this g here. It's no longer there. So here's x2. Now just to find the distance, remember at the beginning we defined delta x as x2 minus x1, which is equal to d. So we'll simply subtract the 2 to find the distance. And this negative will actually cancel with the negative in the denominator. So we can immediately factor out a 1/2 v naught over g. Actually, you can also factor out the square root term as well. So this is 0. I see where I went wrong. You cannot cancel those out. When we solve for x1, what we should have done is switch this sign on these. And then let's try this again. So we're not going to factor anything out just yet. We're going to distribute the negative. So now we factor out the 1 over g. I don't like how long this square root is. That's better. Okay, so now we have 1 over g times v naught times the square root. And this is exactly v naught